For letter A, you're supposed to trace the slope field. Okay, we had those a long time ago, but you got to make sure it passes through 0, 1. So all I do is I start at the point 0, 1 because it goes 1, 2. There's the 3 right there. So I put a dot at point at 0, 1, and then that told me I was going that way. So I went to the next thing and I went that way. And then it told me I was going up in that direction. So I put that there. And so it kept going like up and to the right, and then it went horizontal. And then see how these are pointing to downward. So I just went downward, and then you just went back the other way. It was pointing down to the left. So I kept doing that. I went horizontal. And so you just go like one little thing at a time. If it tells you to go that direction, you just go over to that very next like column thing and then do another thing there. So I got like little pebbles, like just like hopping along the pedals and stuff like that. So just try to look at there. If you stare at that long enough, your eyes will see the shape of that thing, and you just got to make it through that point that they have you do that at. All right, and then letter B, it says write the equation of the tangent line. That's when we need a point in the slope and do your point slope form. And then so they tell us at the point 0, 1, and then we know at the slope point 0, 1 that we got to plug it into the derivative to figure out the slope, right? And so if you look at your derivative, we're going to go 3 minus 1, which is 2, and we're plugging that 0 in for the x there. So I did 3 minus the 1 times the cosine of that 0. Cosine of 0 is 1, so we get 2 for the slope. So then you do your point slope form. Y minus your y value equals your slope times x minus your x value. There's the equation of your tangent line. And then it asks us to use it to approximate f of 0.2. So just take the 0.2, plug it in for x right there. And then just be careful with your arithmetic. You're going to get 1.4 for that answer. Just make sure you read the whole problem. If it tells you to use it for something, go ahead and do that. And then letter C is right in our wheelhouse here, okay? This is not the first time we've seen one of these. We've seen a bunch of these. It says y equals f of x, it says find the particular solution to the differential equation. We know this process. We're gonna separate the variables. Y is with the dy, x is with the dx. We're gonna integrate both sides. Remember the plus c, use a point they give us, the initial condition they give us to plug it in to figure out what that c value is. And then you solve this equation for the y, right? So I go to that first problem, my first derivative there, I multiply both sides by the dx, and then we got to get the y's with the dy. So legal algebra, this is all multiply and divide. So I'm going to divide both sides by the y's, got the y's with the dy, x's with the dx, and once you separate your variables like that, now you're going to integrate both sides. So I'm going to get the ln, because my u is equal to that, the d is equal to a -1, so you got to balance that negative, and you do have 1 over a single letter, so this will be an ln. You integrate cosine, you get sine, because remember the derivative sign is cosine. Always stick that plus c at the side the x's are on. They tell us the initial condition is 0, 1, so plug the 1 in for the y, plug the 0 in for the x. Sine of 0 is 0, so you get c is negative ln of 2, and then plop that back in right there. We got a chunk of points on this thing already. Now we just got to solve this for y, and you know you're supposed to solve for y because it seems like we always do on these problems, and it says y equals right there, so you got to get that y by itself. So whenever I have ln's on different sides, I like to get them all on the same side. So all I did was add the ln of 2 to this side, rewrote it like that, and then you can use your pre-calc properties to combine them, and then you can use your main definition of log where you can go e to that equals that. So I did that, and you can't solve for the y variable when it's in the denominator fraction. So we got to multiply, get it out of the denominator, and then I divided by the e, and then I moved the 3 over, and I divided it by a negative, which switched the signs right there, and then we're done. Marble ride.